Please make sure you have your copy of the assessment review on stoichiometry. What I want to do is go through with you the lab practical experiment, which concerns a very important nutrient in your diet, vitamin C, or ascorbic acid. If you don't have enough vitamin C in your diet, you can get scurvy, a disease that's characterized by open pus-dripping sores and gnarly teeth, bone deformations, and even death. So vitamin C, a very important part of your diet. And some people are concerned about what happens to nutrients like vitamin C when you cook them. What does that do to the amount of the vitamin that's in your food? So on the assessment, there will be a lab practical in which you'll be given a sample of vitamin C that has been cooked for a certain amount of time, and your job will be to use the titration technique that we practiced yesterday to find out how much acid is in vinegar, to find out how much of the vitamin C acid remains in the sample from what it started with. So let's practice that by looking at the problem on the very back. I want to show you an example titration of another acid. The acid is called malic acid. It's named malic acid because it's found in apples, and the Latin name for apples is malus. And so this is a sour flavor that's added to many candies, like this one is Icebreaker sour candy. What I did was I took one of these and I dissolved it in some water, and now I'm going to titrate to find out how much acid is remaining in that mixture. So to do that, I'm going to use potassium hydroxide as my titrant. It reacts with the malic acid, but we can't see the reaction because it doesn't make any fizz. So we'll use a color change indicator to show when enough potassium hydroxide has been added to use up all the acid that's in the mixture. So when you go back to the lab bench for the lab practical, what you'll need to do is give yourself about half a cup of the potassium hydroxide titrant. I'll give you a sample of the acid that you're going to titrate. I'm going to titrate this sample by adding first 5 drops of my color change indicator phenolphthalein. 1, 2, 3, 4, 5. 5 drippy drops, not squirts. Swirl that around. And then I'll use a pipette to add this potassium hydroxide 1 milliliter at a time to the mixture. 1 milliliter is up to this black line. You have to be very careful that you make accurate measurements because each one of these milliliters contains 0.01 or 1/100th of a gram of the potassium hydroxide, and you want to know how much you've added so that you can use that in your stoichiometry calculation. Okay, so I'm going to get my first milliliter and I'm going to add it, and what I'm looking for is a pink color change that turns pink and stays pink, indicating that all the acid has been used up. This is 2 milliliters and 3. I see a pink color in there, but it's not permanent. I can swirl it out. And 4. When I get to a permanent pink color change, then I'll know that all the acid is gone. 5. Each time I do this, I'm using up a little bit more of the malic acid that's in the sample, getting closer to the end point. So that was 6, 7, 8, 9, 10, oop, almost there, 11, 12. Okay, so it took 12 milliliters, or if I multiply that by how many grams there are in each milliliter, 0.12 grams of potassium hydroxide, to use up all of the malic acid that was in the sample from the 1 tablet that I dissolved in there. What we'll do is we'll use that data to calculate how many grams of malic acid were in the candy using stoichiometry.